Look at a least common multiple and our greatest common factor. Let's first look at least common multiple. So given the examples of 3x squared y cubed and 4x to the fifth y squared, and I want the least common multiple of these two monomials. I'm going to start looking at the numbers. So our first number is 3. And I'm going to write down the multiples of 3. So 3, 6, 9, 12, 15, 18. I might need more every now and then, but that should be enough. Then I'm going to write down the multiples of 4. 4, 8, 12. And I notice the first one they have in common is the 12. So 12 is going to start us off as the least common multiple. The next piece now I'm going to look at is between our exponents. So when my base is x and I have x squared and x to the fifth. So I'm looking at multiples of x squared. So if I multiply by x, I get x cubed. If I multiply by x again, I get x to the fourth. And if I multiply by x again, I get x to the fifth. My other x term had x to the fifth. So what we're going to notice here is when we're looking at our powers and with each of our bases, when it's a least common multiple, the higher power is going to be the piece of the answer. So here it's going to be 12x to the fifth, and then if I'm going to compare the 3 and the 2 for my y, I want to take y to the third. So the least common multiple of 3x squared y to the third and 4x to the fifth y squared is going to be 12x to the fifth y cubed, or to the third. And again, when I'm looking at these powers here for each of those bases, I want to take the higher one because as we see, that's going to be the first time they're going to have the common multiple. Let's take a look at greatest common factor, otherwise known as GCF. And let's look at 20x squared y squared and 15x cubed y to the fifth. Now, greatest common factor, the F, we're going to be looking at factors. So if I look at 20, what are my factors of 20? Well, everything is going to go into 1, so 1 and 20. That will be my first factors. Then we have 2 and 10, and then also 4 and 5 is how I list my factors of 20. I'm going to do the same thing for the factors of 15. We know it's going to be 1 and 15. Then we'll go, okay, does 2 go into 15? No. Does 3? It does. 3 times 5 is 15, and we have my factors. So I like working on the outside going inside here, knowing that there's going to be no factors above 15 for the factors of 15, and obviously no factors under 1 there. If you had 2 prime numbers, you would have just the greatest common factor of 1. But I'm going to look at all of these numbers in these 2 rows here, and the only one they have in common here is the 5. Now, if they had 2 in common, you would take the greatest one, hence greatest common factor. So here we have 5. In terms of our powers, let's look at the x variable, x squared. So if I'm looking at x squared is made up of 2 x's, x times x. If I look at x cubed, it's made up of 3 x's, x times x times x. So the greatest number that they have in common is 2. So when we're looking at greatest common factor, I'm going to take the power that's less. So if I'm going to compare y squared and y to the fifth, 2 is less than 5, so that has to be the greatest common factor of the y base here. So 20x squared y squared and 15x cubed y to the fifth, the greatest common factor would be 5x squared y squared.